for those folks who are unable to join us live. They get the benefit of seeing the wonderful recording later. So we got that started. And very quickly, I will introduce and turn things over to Nicole. But before I go into introducing her and her fabulosity, I did just want to say that if you do connect with your microphone or your phone, that you mute yourself unless you want to speak, just so that we can cut back on background noise and things like that. You may not realize it, but even typing on your keyboard is something that we can hear unless you're muted. So you can either use that icon again at the top of the screen, a little phone if you're connected by phone, or of the microphone to mute it. If you are on a phone itself, you can also mute just there directly by whatever features that you have. So without further ado, I'll turn it over to Nicole Reitz-Larson. She is an amazing community ambassador with us with CS for All Teachers. If you're in Utah, like, she's kind of like Miss Utah computer science or something, I feel like. Anybody I meet in Utah that's connected with computer science and education generally, I'm like, hey, you know Nicole? And they do know her because she's pretty awesome. So I'm happy to introduce you to her, and she's going to introduce the rest of our esteemed guests. So have at it, Nicole.
Thank you for the introductions. It's exciting to be on this call tonight. We've got some awesome panelists, so I'll introduce. We've got some pictures up here, and throughout the webinar, we'll hear from each of our panelists, and we'll have the time to do question and answers as well. So we've got Hal Speed, who's joining us. He's the Chief of Global Engagement and Head of North America with MicroBit, and he is the founder of CS for Texas. So we've got his contact information here. We've also got Jacqueline Russell. She is from Microsoft MateCode. She's our project manager. And I read in the chat window, she's from Seattle. I didn't know that. So she's joining us tonight. We've also got Vicki, and Vicki's joining us from LA. She is the CSTA K-8 representative, and we've got her contact information. And we are also welcoming Carl Lyman. He is a retired teacher from Utah and a retired state IT and CS specialist. He loves using the MicroBit and is a coding trainer. So I'm excited to have these folks join us tonight. I know they're super busy, so we're lucky to have them with us. We did do a poll at the beginning. Melissa, if you could bring up the poll results, it would be great to kind of hear a little bit about teachers and if they've used the MicroBit. So we've had about 7 people answer. I don't know if we can still have a few more. Go ahead and let us know if you've ever used a MicroBit. You use them often, if you've tried them once or twice, or not yet, because we would love to have you want to use a MicroBit once we've talked with you tonight. It looks like we've got 6 who use them often. We've got 4 who are trying to incorporate them. So I think by the end of the night, we'll have more of you want to incorporate them with all these resources we're going to share. Looks like we have not had anyone try them once or twice. Either you like them and you're starting them, or maybe we have a bunch who have not yet tried them, but they're willing to be some guinea pigs to try them out soon. So thank you for joining us on the poll here. That kind of helps us out in our conversation tonight as well. So we'd love to hear later on from those of you who have used them, how you're using them in the classroom, and that might help some of our teachers who are new to using them get a little bit more excited. So if we could jump back to the presentation, Melissa, that would be great. All right, I'm going to go ahead and turn over some time to Hal. He's going to start us out, talking a little bit about what the MicroBit is, and he's going to share with us some of his knowledge that he shares with folks around the nation.
Yeah, since we're talking about the MicroBit, I think everybody should make sure we're all on the same page and understand what it is. So in the poll, we talked a little bit about physical computing, and that's using a physical device like a printed circuit board or like robotics or Makey to add to the learning experience for computer science and computing. And there's some great research that actually Jacqueline's team and Microsoft sponsored from King's College London that looks at the benefits of physical computing in the classroom and how it helps the students' learning. It helps increase motivation, Of course, it provides a tangible element, so it's the first time that the kids have the interaction between hardware and software. It also, because there's an additional component and not just the screen time, it adds to collaboration amongst the students so they can build and work on projects together. And then most importantly, it helps to spur and increase creativity, which, as we know, creating is kind of at the pinnacle of Bloom's taxonomy when it comes to student learning. If they're creating something new, that's even better. So the device itself is a small board computer. It's smaller than a credit card that has 25 LEDs on one side with a couple of buttons. And then on the other side are all of the components. It includes an accelerometer, so it knows when you move it or you shake it. I like to tell kids if they've ever played Temple Run and they move or tilt their phone, it's the same technology that's in the phone that's on the MicroBit. It also has a built-in compass so that you can do compass exercises and magnetometer and do things like that, as well as a thermostat, a light sensor, and then probably one of the most amazing things for the kids to tap into is the Bluetooth capabilities and wireless capabilities that the microbits can talk to each other as well as talk to other Bluetooth devices. And so for a device like this that is designed specifically for the classroom as a learning tool, the BBC did this a couple of years ago, designed this with the help of partners like Microsoft and ARM and others. And they ended up raising money to be able to give one to every middle school student in the UK. And then last year, we spun out from the BBC into the nonprofit MicroBit Foundation with the goal to inspire every child around the globe to create their best digital future. So as we all know, in the digital age, every student should be learning these foundational skills. And we believe that they'll better learn these skills with a physical computing device. So with the 1-year anniversary of the MicroBit in the UK, the BBC did some research amongst the classrooms and the teachers about what impact was the device having on their ability to learn computing. Some of you may know that in the UK they have a national compulsory computing curriculum. So every student in every grade is learning some form of computing, and they were able to integrate the microbit and physical computing into the classroom. And here's what they learned after 1 year of having these devices, that 90% of the students showed that anyone can learn code. So it was an easy way, an easy on-ramp, and 90% of them saw this, that I can do this. And that's consistent with what I've seen in students. In fact, my anecdotal evidence would be a little higher, having just come back from the USA Science and Engineering Festival in Washington, D.C. this past weekend, where every single student that came through there was really excited and interested about it. So the second bullet there is that 86% of the students said that they thought that computing and computer science was more interesting. So by adding a physical computing element, they enjoyed the subject more. And most importantly, we saw a 70% increase in the number of girls that would consider pursuing a computing course further in their academic career. So that's a significant jump, and I think it goes to show just how easy a device it is, and tapping into the making and the creative aspects where maybe other forms of computer science learning don't have some of that. On the teacher side, 85% of the teachers thought that it was more enjoyable for their students. And then nearly half of them were more confident as teachers. And I see this quite a bit, that there's some hesitation about, oh my gosh, hardware is going to be tough. I can barely teach software. Please don't make me teach software and hardware together. And I think part of that is based on their experience with some of the other hardware devices that weren't necessarily designed specifically for the classroom and for education. We've really gone out of our way, and the BBC did quite a bit of research initially to make sure that this was suited for kids and teachers in this upper elementary, middle school kind of grade bands. And I think it really delivers on that promise. And once you get a teacher to get hands-on with it, then those interpretations and fears start to melt away really, really quickly when they realize, oh my gosh, this is easy and I can do this. And I think that's a true testament both to the device itself, but then also the work that Microsoft has done with MateCode. Like I said, that's been supported in all of the classrooms for the middle school level, and we continue to, as the MicroBit Foundation, bring the MicroBit to other countries across the globe, including the United States, which we did last year at ISTE, and I think it's going quite well so far. One more slide for me is we have a number of different software devices or software editor environments. Jacqueline's going to talk at length about MateCode, so I'll skip that for now. But there's also a Python editor, so for students that are more comfortable with text-based programming, or maybe older students that are doing more sophisticated robotics and integrating Python, that we have that as an option. And then some exciting news coming later this year in August of 2018. The new version of Scratch, Scratch 3.0, will have support for the MicroBit. So the kids will be able to use the Scratch programming environment that they're used to, but now add the capabilities of using some of the sensors and the I/O capabilities from the MicroBit. Our recommendation with Scratch is that this is for the younger kids, because it doesn't provide a full MicroBit programming environment. It's more you're programming Scratch with using some of the capabilities of the MicroBit. And then as the students start to get more comfortable with that and are ready to do something a little bit more sophisticated maybe than Scratch, then they would graduate up to MateCode, continue to code in blocks, and then I'm sure Jacqueline will show you the additional JavaScript capabilities. But all of these editors, all the software are free. They're all browser-based, multiple platform support across Windows, Chrome OS, Chromebooks, Mac OS. And then we also have additional apps, an iOS app and an Android app, more or less to do the Bluetooth pairing. And then we just announced a Windows 10 beta program on our website for the Windows 10 app that provides some additional features and functionality that Carl's going to talk about later in the webinar today. So with that, I'll hand it over to Jacqueline to show you a little bit more about MateCode.
Great, thanks Hal. Can everyone hear me okay? Yes, thumbs up, I guess. Melissa, would you mind sharing my screen? All right. Okay, everyone. Hopefully you can see my my screen here. Oops. I'm going to just show you MateCode. So I'm the product manager for Microsoft MateCode. We're a hands-on computing education platform. We support mostly physical computing devices like the MicroBit. So you can also program the MicroBit using apps, iOS and Windows 10 apps. And I think Carl's going to show you programming the MicroBit with our Windows 10 app, but I'm going to show you the browser-based version, so it's very easy. There's nothing to download or install, so it's cross-device, cross-platform. Just go to matecode.com and click on the little MicroBit card, and you'll get into our MicroBit editor. A couple of things I want to show you here. On the left side of the screen, you'll see something that looks like an actual MicroBit. This is what we call the simulator, and this will allow you to see, or allow students to see their code and kind of do testing and debugging and get sort of that iterative feedback before they actually download it onto the board. And this menu here is called our toolbox. So this is basically a bunch of different blocks of code that kids can use to drag and drop onto their workspace, which is this part to the right here. This is where they're actually going to be constructing their code. And you can see we've got different categories, sort of the basic category, as well as inputs, music, radio, which is a lot of fun. Students love using the radio, as well as language constructs, so loops, logic, variables, and math. And then we have also some more advanced block categories down here, and partners also write their own packages and their own custom APIs as well. So basically how it works is you can drag and drop blocks of code here. So for example, if I wanted to show an icon on my MicroBit, and you can see how the changes in my code get reflected real time here in the simulator. And for example, if I shake my MicroBit, maybe I want to show a string instead of this icon. The great thing about MateCode is we provide a progression path from this visual block-based programming interface into real text-based coding via JavaScript. And so you can see we've got code completion and, you know, all of the basic things that you would expect from a fully featured IDE. So this is the same development environment code editor that powers Visual Studio Code, so a professional grade code editor. And you can see we also have the same toolbox here, but instead of code blocks, it's got code snippets that kids can drag and drop onto the workspace, so helping them sort of make that seamless progression from visual blocks to JavaScript. And, you know, they can also go back and forth between blocks and JavaScript. Whatever they write in the JavaScript will show up in blocks and vice versa. All right, so once students are done with their program, they can save their program here and give it a name, my demo program, and they can save it off as a MateCode file, as a hex file locally, or they can also share it. So if I click share, it'll give me a URL that I can copy and paste anywhere or give to my teacher, and my teacher can open up my program and comment on it. Now to download my program onto the MicroBit, I can just click this download screen here, and what you'll want to do is take your MicroBit, plug a USB cable, plug the top of it into the small end into the top of the MicroBit, and then plug this big end into your computer. And then once you've downloaded your file, I'm in Edge, but you know, I think Chrome or some of the other browsers work a little bit differently in terms of downloaded files. I can just save this file onto my MicroBit. Notice my MicroBit, now that I've plugged it into my computer, shows up as a drive on my computer. So it shows up as MicroBit D drive. And I'll just save that off onto my MicroBit. And then I've got my program here. So I've got my little smiley face icon, and when I shake it, it'll say hello. So, so that's about it, the basic workings of how MateCode and the MicroBit work. If anyone has any questions, just let me know in the share.
Well, that's super exciting, Jacqueline. It seems like with the MicroBit, it's really a tool where students who might be new to physical computing can engage with the blocks, or students who might have more experience with text-based computing can still engage. And so there's kind of that low floor, high ceiling where you can really take that to different depths as a teacher or after a school class.
That's right. Yeah, it's a very flexible environment, and it's great for sort of that middle school grades, is what I would say, when students are making the transition from like a scratch-based, block-based environment into sort of more real-world programming.
That's super exciting. And with your position with MateCode, how did you get started with MateCode, and what kinds of fun things do you get to do with your position?
Yeah, this is probably the best job I've ever had. It's a lot of fun. So we started working with the BBC several years ago now. It was actually Microsoft Research that worked together with the BBC and ARM and a few other partners to come up with this idea of a mini computer to teach kids about computing education. And so we were one of the founding partners, I would say, and it's been amazing how the MicroBit has just taken off worldwide. I was just at Microsoft's Education Exchange in Singapore, and just the amount of projects I saw from Sri Lanka to Norway to Thailand. I mean, educators are doing amazing things with this device.
Well, thank you so much. As we go through some of these slides to share things, we'll post the slides in the CS4All community. We'll also share them on Twitter. We'll have a link where you can access them as well. And I think that being able to go ahead and use these tools right away is when you're more likely to continue to have access to get excited and practice using physical computing. And we'll talk about where you can get the MicroBit and where we can access resources. Hal shared some really exciting things at the end that will, I think, excite a lot of teachers. One thing I'd like to do is kind of talk to Vicki to find out, as she works with teachers with the CSTA and different places, how have you seen educators use the MicroBit in their classrooms? Because it looks like there's a lot of really fun things that one can do.
There really are a lot of things. Can you hear me? Just want to make sure, since I didn't get to test my mic. Good. All right, so there are tons of things you can do, but I just wanted to, before we go into that, I just wanted to reiterate what Jacqueline and Hal have said. I've seen so much engagement with students, and other teachers have talked about it as well. And to me, a physical computing device, and MicroBit's a great one, of course, they just are great ways for students to learn concepts. I'm a CS teacher, and so I'm trying to teach CS concepts. And it's just a great way for them to learn those concepts and to learn a lot of non-programming concepts as well. I'd like to share my screen, and I'm going to share a document that has a bunch of different ways that people have integrated MicroBit into their classrooms. And when you look at the document, I've started, and I've tried to do it by kind of by curricular area. I'm most interested, of course, in computer science because I'm a standalone teacher. But if you happen to be in looking for an actual course, there's a 14-week intro course that's great to the MicroBit, and it's also great for makerspaces. It's because there's a lot of making involved in it, and it helps so that the kids can get hands-on not only with the MicroBit, but with making things to go with it. I've seen some amazing things that kids have made with the MicroBits. The course itself has a lot of suggested things, but I've seen people go way, way off from those. So it's really limited only to the student's imagination and what they can do programming-wise. What I've seen also that's been kind of fun is people who teach with Code.org, CS Fundamentals course. If you use either course E or course F, which are for basically upper elementary, there are lessons specifically aligned to these courses. So once you've done some unplugged or hands-on things on the computer in those courses, you can then go and do some things with the MicroBit. So now you're not only doing, programming something on the computer, but you're programming it on a physical device. There's a great games curriculum. And then the UK has tons of resources because they've had it longer. There's a whole Key Stage 3 activities that go with their curriculum, which very much complements ours, and they're for students ages 11 to 14, not 4. I will fix that on the document. But any of these things that I'm gonna kind of touch on will it can be used to teach the programming aspects of the MicroBit. One of the things that I love as a computer science teacher is that it helps me to teach like computing systems and file systems. I know Jacqueline showed that you can download the hex file right to your MicroBit, which is great, but I use it as an opportunity to teach file systems and downloading versus uploading because my students always confuse that. And so I use it to teach those concepts and to really reiterate the concepts of input and output. Great data collection, and I know we're going to have a demonstration of some of that later on. There's some great networking lessons. So it's really difficult at a school to do a lot hands-on with networking. Most schools don't want you to touch their network, but you can network microbits together, and kids can see how those work, or use the radio function to have them communicate, which are great. There's some fun cybersecurity lessons available, and I've seen some fun things done with those. The kids like to make up their own, basically their own ciphers and send messages back and forth to one another. But it's not just limited to computer science. If I've seen teachers in language arts, there's lessons that go with some specific books, like Alice in Wonderland. There's a whole set of lessons that go with that. One of my students' favorites is to make a Harry Potter sorting hat. And it's a great first lesson if you're going to get into Python. With Python, a lot of times you'll do it on the screen, but it's great to do it physically. Make a hat, attach the MicroBit to it, and have them have it choose houses. The BBC had a whole bunch of lessons related to Doctor Who. Unfortunately, we in the U.S. can't see the videos that go with us, but all of the resources and lessons are viewable in the U.S. And there's a fun one for making a sonic screwdriver, but you could adapt that and make a magic wand for Harry Potter, for example. But beyond that, make vocabulary games, word games, create animated books, and use some circuits to connect those together. Oops. I think it lost me, didn't it? Did it lose me?
The screen is gone. Do you want us to bring back the PowerPoint original so we can just go off the PowerPoint?
Yeah, just bring that back and we can kind of look at that because the link is still on there. We have that. Do we have that other slide? Or
yes.
We have that next
there
slide.
We go.
Yeah. So some great examples. And in math, of course, anything you're going to do in programming-wise has a lot of math built into it. But you can do plot bar graphs. It's great to explore coordinate grids with it. And then make games based on those coordinate grids. It makes it much more fun for the students. One of the things that I first do with it that ties into math is, we just play with the temperature sensor and show the temperature, but what's interesting is it shows it in centigrade. Most kids don't really see a need to learn the conversion between centigrade and Fahrenheit, but this gives them some real need to do that because they don't understand what a centigrade temperature is. So one of the things that we always do is we have them then show that temperature in Fahrenheit. So it gives them a need to do that, which I think is great. There's a lot of things you can do exploring circuits on the document, which is linked. The bit.ly link will take you to that document. Has a lot of things to do with, there's a great board you can make that'll let you attach things like, or you don't even need one, attach things like LEDs, external LEDs, and speakers and things like that to it. Music, you can actually compose music with notes and work, deal with timing and stuff, and you can then talk about sound and how that works, which is a great thing to also tie then that music class into your science class. Great things in phys ed, you can create step trackers and heart rate monitors, stopwatches, all of those kinds of things. I've seen some, just great projects that the kids have done, like, for example, with a step tracker where they've created this whole thing so it'll attach to their shoe or to their leg and track things and also monitor their heart rate and that kind of thing. So, and it's fun whether you're in a PE class or just do it in a computer class. They like to see that kind of result. So it doesn't have to be that it's just in computer science class, but if you teach computer science, you can also reach out into those other subject areas and help reinforce the learning that's going on in there as well. There's just something about having that physical device do it that it engages a student more, and I think it helps their learning more. I don't have any research to support that, but I've seen it where these light bulbs go on. You can see them kind of go, oh, now I get that concept, whereas they didn't get it when they were programming it and, online. It just didn't gel in their brain the same way it does when it's a physical device that's doing it. I teach K to 8, so I teach some very young kids, and they still believe computers are magic. And even when they program them, even when they're in Scratch and they're programming them, they think it's magic because it's just like a game, and they didn't program Scratch. Whereas you give them this, a microbit that does nothing until you download a program to it, the light suddenly goes on that, oh, they really are controlling something because they're controlling, it's not on their monitor anymore. It's on this physical thing that looks, it looks like it's hardware, whereas the monitor doesn't look like hardware to them. So I don't know if anybody has any specific questions about, how they, about how they would integrate it into their classes, because I could find some examples for that. There's a bunch of examples, a bunch of links on that document. So,
a great place to put your questions is either in the audience chat window, and we can definitely have any of our panelists answer it there. Or if you'd like to raise your hand at the top of your screen, there's a little person up there where you can have your hand raised, and then we can have you unmute your mic and ask if you're interested.
I see that Maureen asked what size groups I use them in. I typically use them in pairs. I like to pair program. But it depends on what they're doing. Like some of the game things that we put together require larger groups. Like there's a fun math game. I don't know if anybody has played the math game Salute, but normally it's played with cards, and two students hold up cards on their foreheads so they can't see, they can only see their partner's card, they can't see theirs. And a third student yells out what either the product is, or they yell out either the addition solution to it, like somebody might have a 2, somebody might have a 6. And the student would either say, if they're doing addition fact stuff, they'd yell out 8. In the other case, they'd yell, they might yell out 12. And then you earn a point by being the first one with a card on your forehead to identify what your card is, because you can't see it. So you can see the 2, for example, if you have the 6. Then the third, so that third person could, so you have 2 people who have microbits that show the random numbers on them. Simple game. You could have then a third student either program a microbit that keeps score, or all they do is telling them what the answers are, either the addition problem answer or the multiplication. And then they have to go backwards, figure the subtraction or the division to get the math fact. So, it's a simple little game. It's a fun game, but now you're programming it with the MicroBits. It makes it a lot of fun. So, things along that line. Vocabulary, when you're, if you're in a foreign language class or an English class. Create it, if you've ever played the headbands game or the whatever, or the one that Ellen does, where you've got to guess what the word is. Well, you could do that with vocabulary. So it's kind of very fun to do those kinds of games, and then they can make something to attach it to their forehead and make it so they're using the accelerometer so they know, when they put their head down, it gives a point. When they put their head back, it gives a new word or, whatever. So they're using the features of, they're basically making their own game like one they may have played in the past, but now you're reviewing content for a subject area.
Well, I love the idea
kind
of having this. Yeah, I love having the idea of students coming up with the programming piece and the physical piece where, make the headband to put around your head, or come up with those computational practices of, let's do storyboarding. What is it that you want it to do? How do we use math? Because you still have to know the math to make the game. And I think a lot of teachers kind of get nervous when they do technology, but to see that using the MicroBit is very easy with the interface. It's not as intimidating. And a lot of times you give the kids a starter and they just jump and do amazing things. And looking at some of these activities, I think students can go really far with just a little bit of help.
Right. It doesn't, and what I find is when I leave it open-ended and say, okay, now I'm going to show you these things you can do with it now. Go create something. I mean, they come up with stuff you wouldn't even imagine. It's like in the music realm, for example, I have some kids that are very much into music, and they create some amazing musical instruments that, they kind of play with the MicroBit, creating circuits so they can, press buttons or do whatever to make it play whatever song they want. Or the kid who can't program a song can use the built-in sounds and, just make a sound box and still wire things in with a circuit board. Everything that's on the document I've listed is pretty much uses the MicroBit, and maybe some minor add-on things like craft materials or LEDs and alligator clips and things like that. But there's so many additional things that you can get that attach to the MicroBit that, you can even do robotics with it or whatever. It's great. I mean, it's very expandable, which is one of the reasons I love it. It's easy to start with, but it's definitely got that high ceiling. It's definitely the low floor, high ceiling.
Fantastic. Thank you, Vicki. Let's go on to Carl and find out some of the things that he has done with the science and using the MicroBit. And as Vicki was talking about some of the ways that you can connect crafts or different things, I know with science, Carl has taught different scout groups and after-school groups using the MicroBit and bringing in some extra accessories. So Carl, if you would like to tell us a little bit about how you've used the MicroBit with some of the different groups you've worked with and science. That would be great.
Okay. You can hear me there? Yes?
Yes.
One of the things that my first experience was the MicroBit. I was to a conference. Somebody gave us one about a year ago. I brought it home. I had a couple of grandkids staying with me. And my grandson that was in 6th grade, I showed him how to do what Jackie showed us here today. And just enough to display his name and a picture. And he says, you know, I think I could make a calculator out of this. An hour later, he had a 4-function calculator that let him choose these two numbers, and I thought, this is an amazing thing. If kids can take, having never seen them or never seen the programming environment, and create something like that. And what I want to show you is just a little bit, some things that there. Melissa, do you want to set it up so I can share screen there? Okay. One of the things that that was alluded to earlier was the 14-week course. If you go to MateCode microbit.org/courses, you see the Introduction to CS course there. There's a science experiment. If you look at those, there's some links to some projects down there, and that's one of the things that I like is about them is what Vicky's talked about is how good they are to do cross-curricular activities with them. One of the things that I've done and looked at is different ways to collect data with them. Probably the easiest is to just use some of the sensors and display the results on the LED screen. Again, the students can get immediate feedback with what's going on. One of the other things with the MateCode app that runs in Windows 10, you can see that now. It looks just like what you see in the browser, but it does some additional things that are not available in the browser, and that is that when you have your MicroBit connected to the MateCode app, you can write data from that you collect from the MicroBit back to your app and view that. And I'm going to do a short demo of that. I'm going to pull the forever off. One of the things I always have my kids do is with an on-start is just tell what it is that's going to be doing. And so I just have them put in there. And I usually have them do it in all caps, what's going on. Then I'm going to pull in a loop that's running forever. I'm going to come down to the serial. I'm going to write some serial data back to the screen. So I'm going to do a serial write value, and I'm just going to put in there that I'm writing electricity, and the value that I'm going to use, I'm going to pull from my pins. I'm going to read one of my pins. I'm going to do a analog pin read, an analog read pin from pin number 0. So I have my MicroBit connected, and I have a wire connected. I hope you can see that. I just went and stole some wire out of an old Cat 5 cable, which worked really well. And now I'm going to go download that to the MicroBit. One of the things about the MateCode, you just hit the download and it writes it directly to the MicroBit. So over in right under the simulator, I have two boxes. One that says show data from the simulator and the other that says show data from the device. So I'm going to click on the show data from the device, and I'm holding my hands on one of each of the wires, and you start to see that I'm getting some data collected in the window there. And in a minute, as soon as that first big hump goes away, we'll start seeing a better view of what that data looks like. So I'm collecting that data. There it is. You can see what I'm collecting from the electricity out of my fingers. One of the cool things that can be done once I've collected some data is up in the upper right-hand corner, there's a download button. I click that download button. It brings up my spreadsheet. I open it up, and now I have a set of data in my spreadsheet that I have. First column is time. The second one is the value that was brought in. And I could graph that. I could go in and do some additional analysis of that data there, which to me it's been really cool. The other thing that we've done with data collection is take one microbit, set it remotely somewhere that we're collecting data, and have it radio talk back to another microbit that's connected to the MateCode app. And so I can send data remotely, record it, and also collect the data, view it, using any of the sensors that are built in, or additional ways to do that. One of the other ones that I've played with a little bit is there is an option. I'm going to go over to the gear on the right. I can add a package, and I can search for file system, and it's a beta package. I can add that, and now I have some things that I can have my microbit almost act like a USB, that it can collect data. I can then have it write that data back to my display like I was showing before, and collect that data that was recorded remotely. And I've not got stuff written up on that, but I think it offers a real good opportunity to collect data remotely and then being able to download it.
Now, Carl, as you've been sharing these science experiments with people, what is the cost for something like that when you go in and do it with the group? Is it very expensive when you think about a regular science class that's going to bring in all these different tools and beakers and different things? What is the cost as you're sharing that with teachers and scout groups and different things?
To me, that's one of the things that's really nice. If you look about any kind of data collection device, with a microbit, you can do it for $16.50 in the U.S. And it has so many built-in sensors that there's virtually no expense to be able to do that, compared to what, if you look at some of the commercial science data collection, they're sometimes $100 or $50 just for a single probe to do stuff. So I think it opens up lots of capabilities for students or teachers to be able to try different kinds of experiments. Looking at the accelerometer, what could you do with the accelerometer if you can connect it remotely and have it radio information back with doing things with motion, or shooting a rocket into the air or something like that? I think, it's like Vicki says, the entry level is really low to get started, but there's no limit with what students can do or go with.
Fantastic.
Okay.
Melissa, do you mind sharing with us the PowerPoint? Well, Carl has a bunch of resources which we have in our document that we'll share. He has done a lot of presentations with teachers at different conferences, showing them how to use the MicroBit. Right here, he's got this link right here that you can go ahead and access, and we can also share some in just a little bit. So we've got just a couple minutes. I would love to find out if you have any questions. Our panelists have been busy over here in the audience chat answering things. If you've got any last-minute types of things, we've got a few more accessories to share, but we don't want to overwhelm you with more before we hear any questions. You can put them in the chat window or raise your hand at the top. Looks like we've got some open source items at GitHub. Hal shared that we've got the microbit.org/testing to give feedback. Vicki even gave her personal email if you want to send Vicki a personal email as well. She's opening that up to everyone. And it looks like we've got some questions about workshops coming up as well. This is exciting. All right, let's go ahead and looks like we've got some resources in here. How do you want to share a little bit about these resources? It looks like you probably snuck in there, or maybe Jacqueline, and we can let people know what awesome things they have here.
Yeah, there's a combination of things. Most of these you can navigate to if you just go to microbit.org and go to the teacher tab. That's where some of the research, I saw Philip Eaglin was asking about Sue Sitton's research. There's a link to that there. We have lessons aligned to the Course E and Course F of the code.org curriculum. So if you're a teacher that's already teaching the CS fundamentals in elementary school, this is a great way to add a physical computing element to the code.org elementary curriculum. Jacqueline's already talked about the 14-week middle school curriculum that's also available at that website. And then if you're a Project Lead the Way school, there's a dedicated middle school course in the Gateway program called Computer Science for Innovators and Makers that is focused on making with the MicroBit. So there's 3 units in that, and they all use the MicroBit. I saw one of the questions in the chat was about where to purchase microbits. So if you go to microbit.org resellers or just go to the buy menu on the microbit.org website, that'll list the worldwide resellers, and then you can scroll down to the US or Canada or whatever country you might be in. For those of you that are in the US, it is available on Donors Choose. I would recommend using AKJ Education on Donors Choose, since their prices tend to be a little bit lower, but I have seen other teachers use Amazon as a choice on Donors Choose, or a couple options there. And I didn't really include it, but Carl mentioned that there's a couple of different package configurations where you can buy just the board. That's usually about $15, or the board, a USB cable, and a battery pack is about $16.50. And then there's a classroom set of 10 that includes 10 boards, 10 battery packs, and 10 cables, which is usually about $145 or so.
Awesome. And then we've got these great accessories that you can add to the MicroBit, which is super exciting.
Yeah, like was discussed earlier, that there's so much already integrated into the MicroBit. I mean, don't feel compelled that you need to rush out and buy accessories to bring the MicroBit in your classroom. There's so much learning that can already be had, and just like Carl showed, with some wires or some conductive tape or some cardboard. And then as you look to raise that ceiling, there are some additional kits. This is just some examples. There's a whole catalog on the MicroBit website, but whether that's adding some multicolor LEDs, our robotic kits, our game controllers and arcades, our external speakers, or even doing electronic modules, so starting to bridge some basic electronics in resistors and, well, potentiometers are resistors, but buttons, resistors, little motors and fans. That's a way to easily do that in a modular format without having to do all of the complexity of the wiring in the classroom. So part of what we're trying to do is abstract away a lot of that complexity so that we can focus on the learning. And then a few new things that I just wanted to highlight. If you happen to already be using the Hummingbird Kit from BirdBrain Technologies. They recently announced a MicroBit adapter board that will snap onto your Hummingbird Kit and allow you to integrate MicroBit into that environment. And then Kitronic has a pretty neat little game zip device that all those little white squares are multicolor LEDs, and then you've got the 4 directional buttons on the left-hand side and a couple of buttons on the right-hand side. So for kids who want to create games and add multiple colors and sound to that, this is a pretty creative way to do that. And then Vicki already mentioned the MicroBit in Wonderland book, and I'm glad to see a classroom teacher enjoys this as much as I do. I think this is a wonderful resource for both boys and girls. It's available on Amazon in print form, or there's also an ebook on the website link there. And then if you want to get an idea of what's in the MicroBit,
Well, I want to thank all of you for joining us tonight, especially our panelists, to share all these amazing resources and talk about ways that we can integrate it with so many lesson plans. And as Carl shared with us, things that don't cost a lot of money so that we can actually bring it to our class. I like the way that Vicki talked about even doing 2 people per microbit. Even though they're not very expensive, you can still have 2 folks on there kind of doing that pair programming and talking about their ideas and strategies for what they think is going to happen, make those predictions, try it out, see if it works. If it doesn't work, go back to the drawing board and see what might happen next. So this has been an awesome webinar tonight, and I want to thank Carl and Jacqueline and Hal and Vicki for joining us tonight. We do have a webinar coming up later this week with K5 and making, and then on April 25th we have another webinar with students becoming storytellers with data. So we have a lot of things coming up, and it's exciting to have folks join us. The CS for All community is always hosting webinars, having Twitter chats and different things to get teachers engaged. So it's super exciting to be part of this community. We'll definitely share out the PowerPoint and the different resources so that you all have access to those. Are there any last thoughts from our presenters or from Melissa before we decide to end our webinar close to being on time here?
I just want to say a special thank you to everyone. This has been amazing. The chat conversation has been great. I'm loving the sharing of resources and the helpfulness of everyone. So just a round of applause again for this amazing panel and being here to share the information with us. We really do appreciate it.
Great. Thanks, everyone.
Thanks for joining us tonight.